So, okay, let's say we have two tissues, a tumor and normal tissue. They have the same T2 star properties. They have the same T1 properties. So if we're trying to tell them apart, it's not going to work to do that trick of making the echo time, the time when we sample the signal, long, right? Because the T2 star is the same. It doesn't matter if we wait a longer time. Those T2 star curves are not going to separate. So we can't tell them apart. And if we try to repeat the pulse sequence before we've recovered all of the longitudinal magnetization, that's not going to work either because the tumor and the normal tissue in this hypothetical example have the same T1 properties. So we have to do something else, and I basically gave away the answer. We have to give gadolinium. So what is gadolinium going to do? Gadolinium is going to get absorbed by the tumors preferentially compared to the normal tissues typically, because the tumors often have leaky blood vasculature, and so when the gadolinium goes into the tumor blood vasculature, it leaks out and then gets into the tumor and it hangs out in the tumor. Whereas in the normal tissues, it doesn't leak out as much. The blood vessels are not as leaky. And so gadolinium has a property where it shortens T1. So on a T1 weighted image, this is going to make the tumor appear relatively bright compared to the normal tissue. Same mechanism as before. So if we want to see the tumor, we just need to have a short repetition time, because that's going to bring out this difference on the T1 recovery curve. But in this case, it wasn't a property of the tumor itself. We had to give contrast, give the gadolinium to make the tumor have a shorter T1. So there you go. Okay, so now I think we are at the last part. Let's see. Yes. So now we're going to talk about proton density contrast. So I'm going to try to make this very simple. Okay. So essentially there are two things that you have to remember. Number one, T2 star weighted images are going to have long TEs. Number two, T1 weighted images are going to have short TRs. Fine. So long TE is going to generate T2 star contrast. Short TR is going to generate T1 contrast. And you don't even have to memorize that. If you can reproduce those graphs, you can derive these facts that I'm telling you. So if you want to figure out, well, what do I want the TR to be in a T2 star weighted image? Think about it like this. We just want to, if a short TR is going to generate T1 contrast, in a T2 star weighted image, we're going to want to minimize T1 contrast. A T2 star weighted image, we want the contrast to be primarily due to the T2 star properties, differences in T2 star of the different tissues. So to minimize T1 contrast, we're going to do the opposite. Instead of a short TR, we're going to have a long TR. Similarly, for a T1 weighted image, we're going to want to minimize T2 star contrast. How do we generate T2 star contrast? We use that long TE relative to where signal is maximized. So if we want to minimize T2 star contrast, we're going to want a short TE. So that's how you can figure out that T2 star weighted images have long TR and T1 weighted images have a short TE, right? Because we're just trying to minimize the other kind of contrast. So if you want to generate a proton density weighted image, what kind of MR sequence parameters do you think we're going to want? Well, we're going to want to minimize T2 star contrast. So we're going to have a short TE. We're also going to want to minimize T1 contrast. So we're going to have a long TR. It's that simple. In summary, T2 star weighted images are going to be generated by using long echo times relative to where we would maximize signal. We want to wait for those T2 star curves to separate before we sample the signal. T1 weighted images, we want to use a short repetition time, the time between these 90-degree radiofrequency pulses, so that we take advantage of these T1 curves separating before they come together at the end. So a short TR relative to where signal would be maximized over here. And a proton density image, we want to minimize T2 star contrast, so we want to do the opposite of what would generate a T2 star weighted image. So instead of a long TE, we want a short TE. And we want to minimize T1 weighted contrast, so instead of a short TR, we use a long TR.